Hey, it's Radical Dan. Start with this, which is wood ashes, hardwood ashes. Soak it in water for a few days. I don't know if you can see it now. There's a little clear layer. All the sediment fell out of it, so I took the clear water off of it, which I've already done. And then the clear water is a potassium carbonate. So this is hydrated lime. Each 50-pound bag is like $8 because the the solution that you get is, contrary to popular belief, it's not potassium hydroxide, potassium carbonate. And potassium carbonate will not eat aluminum. So when we put the calcium hydroxide in the potassium carbonate solution, then the calcium carbonate, which is a solid, and it precipitates out of solution and it leaves it potassium hydroxide. You see, that's my pH tester for plants. See, it pegged the meter, so it's way above 10. An alkaline is usually around 12 or 14, like a sodium hydroxide like 14. So, if you can see it, it was attacking the aluminum. You can see a little bit of bubbles coming off of it right there. Okay, this is the, I'm reading, it's off the scale. My scale only goes to 10. That's the alkalinity, so it's about a 14, which is the highest you can get. So that tells me it's very alkaline. And the only thing that can cause that would be, well, the carbonate gets a little alkaline, but when I put the lime, the hydrated lime, which is calcium hydroxide, when I put it in there, it displaced the potassium carbonate that was in the ash water and replaced it with potassium hydroxide. And then I had a solid of calcium carbonate, which is a white soupy stuff that I had to filter out. But just to show you, this is a piece of stock aluminum that I cast and then I turned down on my lathe, and I use it for experiments. But I'm going to drop in here and get some hydrogen started. You see it. I'll pop up here in a second. Yeah, there it goes. There it goes. And watch the bubbles. See those bubbles? I put a tiny couple drops of dish soap in here, so it should form the bubbles on the top, so where you can light them, and they'll go pop, 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 because it's hydrogen. So. Ooh. A little more molly to give me a big bubble up here. And drop a little bit in there. Some kind of cheap soap. I don't know what the fuck it is, but anyway. Alright. Get us a big one here. There we go. There's some bubbles right there. I'll light this with a torch, but I'm not going to fuck my hand up. But you should hear it. Let it build up some. But anyway, that's the whole idea. You can take your ashes and save them and sift them and then soak them. Probably if you soak them in hot water first, the process would be a lot quicker. But what that does, that leaches out the potassium carbonate, and then by a displacement reaction, you can go get hydrated lime, which is what they use in like construction. It's well, they do basically they take limestone, or they take seashells, they take eggshells, or anything that's made out of calcium, and they'll put it in a kiln and they'll burn it real hot. And what it does is it breaks it down to a calcium oxide, which is CO or CaO, yeah. And then when you add water, a little bit of water to it, they call it slaking, which turns it in. You know, it draws out oxygen, and well, it draws. It basically mixes the water. It mixes the calcium hydroxide, which is CaOH, and which is caustic. And because potassium is more reactive than calcium, when you put them in solution, they will do the double reaction, and potassium takes calcium's place, and then the calcium is left over to take what potassium had. So that's where you make potassium hydroxide. Let's try it. time pops in there. So yeah, that's aluminum. So you can basically produce hydrogen gas from ashes and lime and aluminum. I will try later to break it down. Maybe concentrate it a little bit more, something like that, but I just want to make sure I can do it. Yeah, you can see the bubbles on there. Alright, Radical Dan, have a good one.